Advanced GraphRag 2, the next 5 families. Let's dig in. Everything in Part 2C was the read path. 4 fields, a half-open interval, a query with 2 dials. And I told you that was the easy half. Here is the bill. Every one of those tidy intervals had to be written by something. And that something had to decide at ingest time that an old fact had ended. This whole submodule lives inside one moment. A new fact arrives and it disagrees with one you hold. Before we get to contradiction, look at where contradiction actually lives. Every fact arriving at a temporal store hits a decision point, and there are only a few ways out. It might be genuinely new. It might be something you already know, word for word. It might sharpen a fact you hold, or it might flatly disagree with one. 3 of those are cheap. The amber one costs you a model call. Let's clear the cheap ones out of the way. Genuinely new? Nothing you hold touches it, so you insert it and you're done. That is the overwhelming majority of writes. Already known? The same fact arriving again from a second source, so you note the citing rather than insert a duplicate. And refinement. You knew Dana Reyes ran technology somewhere. Now you learn it was Meridian Labs. Sharpening is not contradiction.
The 4th exit is different in kind. Here, the new fact and the old one cannot both be true at the same time. Dana Reyes is Chief Technology Officer of Meridian Labs. Dana Reyes is Chief Technology Officer of Helio Systems. 2 reasonable sentences, both in your store, and one has to stop applying in March. Nothing about the shape of those records tells you that. The conflict is in what they mean. And here is the slide that earns a language model a seat on your right path. Look at these 2 sentences. Works at Meridian Labs. Joined Helio Systems as Chief Technology Officer. Count the words they share. 0. Not one token in common. No overlapping entity string. Nothing a keyword index would catch. And yet you read them and knew instantly that one of them ended. Something has to actually understand the sentences. So the right path gets a language model, and that is not architectural fashion. It is the only component that can make this call. The published description is refreshingly blunt. The system employs a model to compare new edges against semantically related existing edges to identify potential contradictions. Notice what that commits you to. Your ingest is no longer a database insert. It is an insert with an inference step wedged in front of it. If a model compares the incoming fact against existing ones, which existing ones? Compare against everything, and your write cost grows with your graph, which is a wonderful way to make ingest slower every week. So you shrink the candidate set first, search for related edges, then keep only those sitting between the same pair of entities, Dana Reyes and Meridian Labs. 3 candidates, not 3 million. The model sees a handful. One more filter, and it is the one people skip. 2 facts can be semantically incompatible and still both be perfectly true, just not at the same time. Dana at Meridian and Dana at Helio do not contradict each other in any absolute sense. They contradict only where their validity intervals overlap. Pull them apart in time, and you have a tidy succession. So the real test is a conjunction. Meanings collide and periods collide. Let's watch the whole thing happen on the 2 clocks. The Meridian record opens last year and runs off to the right as an open arrow because no ending was recorded. Months pass and nothing is wrong. Then March arrives, carrying a fact that cannot coexist with it. Watch the right end of that capsule carefully. It does not vanish. It acquires a hard edge at March, and the successor opens at that instant. Strip the animation away, and here is the entire operation in 2 lines. On the world's clock, T valid 2 of the old edge becomes T valid from of the new one. On the ledger's clock, T expired of the old edge
becomes T ingested of the new one. That is genuinely all of it. 2 field assignments. Now look at what is not here. No delete, no remove, no drop. The implementation is 2 equal signs. Take that first line alone, because it is doing something quietly elegant. The successor's start becomes the predecessor's end. The same instant written into 2 different records. In Part 2C, we argued for the half-open interval, where a boundary instant belongs to whoever is starting. This assignment is what produces that tiling. You never compute a closing date. You copy the opening date of whatever displaced it. No arithmetic left to get wrong. Now, the second line, which is the one teams forget entirely. The old fact stopped being true in March, but your store did not know that in March. It went on cheerfully asserting the Meridian record until July, when the announcement landed. So the ledger clock gets its own closing stamp at July, sitting somewhere completely different from the world's ending in March. 2 endings, 1 edge. The gap between them is how long you were wrong. Let's be concrete about what changed on disk, because invalidation is a very big word for a very small diff. Before, 1 row, Dana Reyes, Chief Technology Officer, Meridian Labs, both right-hand fields empty. After, that same row, in the same place, with 2 fields now filled in, and 1 new row underneath it for Helio Systems. Count the rows that disappeared. 0. The store got longer, not different.
So why bother instead of 1 clean update? 3 reasons, and the first shows up at 2 in the morning. Something answered a question wrong, and somebody needs to know why. If you overwrote the old value, the evidence of the mistake was destroyed by the fix. If you closed it, the wrong answer is still sitting there with its dates and a link back to the document that produced it. You can point at the row. Second reason. The entire read path from Part 2C only works if nothing was destroyed. Ask what was true in February, and the answer has to come from a record that still exists. Delete the Meridian row, and every as-of query reaching back past March quietly returns less than the truth. Not an error, just a thinner answer, with nothing to tell you something is missing. Closing keeps that row eligible for its own windows. Third reason, and this one saves you from yourself. Contradiction detection is a model call, and model calls are sometimes wrong. Suppose it decides Dana's 2 roles conflict, when in fact she held both, a board seat and an operating job. If you deleted, that fact is gone, and you are restoring from backup. If you closed, the repair is 1 assignment. Put the ending back to empty. Nothing here destroys anything, so everything is reversible. Now, the honest other half, because I have spent 9 slides telling you never to delete, and that is not quite true. A person exercises their right to erasure. That is not a fact becoming false. Nothing in the world changed. A legal obligation arrived, and it demands the opposite operation. Not record that this stopped applying, but make it as though you never held it. Conflate those two, and you satisfy a compliance request with an end date. And erasure is far harder than deleting 1 row, because that fact did not stay where you put it. It seeded entities. It flowed up into a community summary. It got quoted in a cached answer. Closing the interval leaves every one of those copies untouched, which is precisely why closing is not erasure. Real deletion walks every provenance link the fact traveled, while leaving the neighboring facts that never touched it alone. And here is the twist that makes all of this hang together. Those provenance links you built for auditing, whose only job was to answer why did it say that, turn out to be the exact index you need in order to erase properly. A store that cannot explain itself cannot delete itself because it has no idea where the fact went. Keeping history is not in tension with forgetting. It is what makes forgetting possible.
One warning before we leave this, because the industry keeps relearning it. A deleted flag is not erasure. An administrator can still relearn it. Administrators can still read the row, and regulators know that. Worse, in vector stores, soft-deleted embeddings have been shown to remain reconstructible from the index itself. The pattern that actually reconciles an immutable ledger with a duty to erase is to encrypt each subject under its own key, then destroy the key.
Right, that is the mechanism. Now, the part that only shows up in production. 4 failure modes, and they split neatly into 2 pairs. 2 are failures of judgment, where the model made the wrong call about whether facts genuinely conflict. The other 2 are failures of timing, where facts arrived in an order or carrying dates your write path was not expecting. Let's take them a pair at a time.
Over-invalidation. You closed a fact that could happily have coexisted. People hold 2 roles. A company has offices in 3 cities. Close one and you have quietly deleted a truth. Under-invalidation is worse in a subtler way. The model missed the conflict, so both facts stay open, both come back, and your assistant asserts 2 incompatible things in 1 paragraph. Over-invalidation loses information. Under-invalidation manufactures it.
Now, timing. Out-of-order arrival. July's announcement reaches you before June's correction, so the fact you close is the wrong one. Your write path assumed the newest thing it read was the newest thing that happened, and Part 2b told us that is exactly the assumption you may not make. And clock skew. 2 sources stamp one event 5 minutes apart, so your half-open tiling acquires an overlap. Neither is a model error. Both are ordering.
Step back and look at what we have built. A static graph's write was 2 steps. Extract, then insert. This write is 4. Extract, find candidates, compare with a model, then assign. And those middle 2 are paid on every ingest, whether or not anything contradicts, because you cannot know there was no conflict without looking. Module 1 asked when you pay for understanding. For a corpus that moves, you pay on the way in. So we now hold the complete primitive. 2 clocks, 4 fields, a half-open interval, an as-of query, and a write path that closes rather than destroys. What we have carefully avoided is naming a single product that implements any of it. That changes next. In Part 2e, we meet the reference implementation properly. What it is, what its objects are called, and what happens when you hand it a message. See you there.
If you like this video, please subscribe and share. Thank you.